Hello everyone, myself Dr. Shailendra Kumar, Assistant Professor in the Department of Electrical Engineering, IIT Bhilai. Here I am going to tell you about the introduction of EVs charging station systems. So in this lecture we shall discuss about the different components of a charging system and the status of charging infrastructure in India. So, if we go to this component of a charging system, here there are 5 components of a charging system, and it can be seen in the figure also. So, basic components are energy source, energy storage system, power electronics converters, and you can see in the figure the power converters, it is connected with all the components, where it is interfaced with the energy source, it is interfaced with the energy management system, local loads, distribution network, grid, EV spot, as well as energy storage system. And further if we are moving, then we have EV charging spots, energy management system, renewable energy source. So, there are solar, wind, biomass and fuel cell which are integrated in the charging station. So, here we can see these power electronics is playing major role while we are developing a charging station. So, in this particular development of charging station is basically depending on the conversion from AC power to the DC, as well as this DC conversion to control the charging current which is going to the battery. So, this way if we move further, we have energy storage system. So, if there is outage from the renewable energy side and there is outage from the grid side. So, we need to have these energy storage system. We can provide the power to the EV electric vehicles under outage of PV source, wind energy conversion system, as well as under outage of grid. So, these energy storage system can play a major role for establishment of the charging station. And other side we have power electronics converter. So, these power conversion units are essential for converting AC to DC and these DC to AC, as well as regulation of DC bus voltage current. So, DC converters are also required. And we have various type of power electronics converter, DC, DC AC, as well as AC DC. And at the figure we can see multiple multifunctional charging infrastructure which could have the V2G as well as G2V facilities. Apart from this, it must have other functionality like grid to home, like PV source to home, PV source to grid, as well as PV source to electric vehicles. Then we have energy management system. In the charging station, energy management system also playing a vital role. It manages charging based on availability of renewable energy generation and grid. It could this charging station could operate in various modes. As talked about earlier, it can operate from grid to vehicle, vehicle to grid, grid to homes, this PV to grid, PV to load, PV to vehicle modes. This energy management system also communicates with various energy sources, energy storage system, EV chargers, power electronics converter and utility grid. It also manages the burden on the utility grid. Let us suppose we have a various number of EVs, large number of EVs which are connected with the grid. At the same time we have load requirement, power which is required by the load. So, at that particular moment we need to we will feel there is burden on the grid. So, we have to think about some alternative arrangement by which we can integrate these renewables and we can reduce the burden on the utility grid. It could also if we have integrated some kind of control algorithm, it can also improve the power quality through having some power converter unit which can help in improvement of power quality. It can also tell you the status of battery, state of charge, depth of discharge of the battery. Now, status and trend of charging infrastructure. So, if we see in 2022 there were 2.7 million public charging points which were available worldwide, and at the end of this 2022 there were 2.7 million public charging infrastructure, and within this year only in 2022 there is installation of 900,000 charging station, and it is 55% increment as compared to the charging stations which has been established from 2015 to 2019. While most of the charging demand is currently met by home charging, and publicly accessible charging are increasingly needed in order to provide the same level of convenience and accessibility as for refueling conventional vehicle. So, we can assume these battery electric vehicles, hybrid electric vehicles as a petrol and diesel fossil fuel based electric vehicles. We have to refuel these vehicles within half an hour or 40 minutes. So, we need public charging infrastructure, fast charging infrastructure to achieve these goals. In dense urban areas, particularly when access to home it is more limited, and public charging infrastructure can play a vital role for these EV adoption. Publicly accessible fast charging infrastructure, especially those located along with motorways like highways, enable longer journey and can address range anxiety, which is a big barrier for EV adoption, and other barriers like slow chargers. They are also need to we must have these fast charging infrastructure so that our vehicle can be charged within 30 or 40 minutes. The number of fast chargers increased by 330,000 globally in 2022, and the deployment of fast charging compensate for the lack of access to home charge in populated cities, support the goal for rapid EV deployment. So, if we see EV infrastructure in India, a robust nationwide charging network is crucial to promote ongoing EV adoption in India, and it can assist EV owner in two ways. The first one, charge their EVs quickly and conveniently. Second one, it will eliminate drivers' concern about running out of charge, as range anxiety is a primary concern against EV adoption. Now, after this Indian government has think to development and adoption of these electric vehicle. So, they in 2015 they have launched this FAME scheme, which is nothing but faster adoption and manufacturing of electric vehicle. So, initially they have launched FAME 1, and later on after completion of FAME 1 they have launched this FAME 2 scheme for faster adoption of electric vehicle. So, under FAME scheme, the scheme provides incentives for EV adoption and charging infrastructure growth, establishment of a widespread charging network to support the growing number of electric vehicles. Priority is given to the electrification of public transport, which may include electric buses, three-wheeler rickshaw, as well as other public transports, aimed at reducing vehicle emissions, improving air quality. We can see the air quality cities like Delhi and other cities in India. So, adoption of electric vehicle in these cities is very important, as it can improve the air quality and decrease the dependency on fossil fuel by accelerating the adoption of clean mobility. Now, other scheme which has been launched by government of India, that is Nation Electric Mobility Mission Plan, that is also known as NEMMP, which also giving the incentive under EV purchase. So, the primary goal of this scheme is to encourage the adoption of again electric vehicles as well as hybrid electric vehicles, which is the combination of IC based electric vehicle and battery electric vehicles, which may reduce the dependency on fossil fuels, as we can increase the range of this hybrid electric vehicles. So, they contribute to the national goal of reducing greenhouse gases as well as the emissions which has been produced by these gases, and improving the air quality in urban areas. To promote the use of EV through financial incentives, subsidized and awareness program to encourage consumer to switch to electric mobility. Establishment of a widespread and reliable charging infrastructure to support the growing number of EVs on the road. Creation of a conductive policy and regulatory environment to facilitate the growth of electric vehicle sector. Also, Indian government support for research and development to improve the EV technologies and bring down the cost. So, in Indian institutes, or we can say different R&Ds in India, they are working on different part of electric vehicle. Some people are working in the motor drive, so continuously they are working to reduce the size of these machines, as well as they are working on to improve the efficiency of a particular drive. Other people, they are working on charging infrastructure. Some mechanical engineering people, they are working on overall design of the vehicle, so that we can improve the efficiency of overall a vehicle, and the cost also we should bring down. So, establishment of mechanism to monitor the progress of mission and track to adoption rates and evaluate the impact of the policies. So, here we have the success of these government initiatives for charging infrastructure, which also depend on private sector investment. It is not only like that the government schemes are sufficient for adoption of electric vehicles. Private sector must come forward, so that the growth of electric vehicles could be more as compared to previous scheme launched by Indian government. As Indian government are targeting all the vehicles will be on the road, all the vehicles on the road will be electric vehicles by 2030. So, to achieve these goals, private sectors will play a major role. The government alone cannot create a robust and extensive charging network on its own. Private sector players, including charging infrastructure provides and Resident Welfare Association (RWA) should contribute to charging infrastructure deployment as well. So, in every city as well as in every localities, we need to have the charging infrastructure so that ED adoption could be increased. Private sector investment may have the additional benefit of fostering innovative business models such as battery swapping and smart charging. This can make charging more affordable and convenient for EV owners. It may be easier said than which has been done till now. So, we have public charging infrastructure installed in India. We have fast charging, slow as well as moderate charging, and under fast charging we have different chargers like CCS and ChargeMO. CCS is the US made charger which have minimum 50 kilowatt. Nowadays people are going more than 50 kilowatt, and the voltage rating of this CCS, it is varying from 200 to 750 volt. It has one connector gun and it could be used for 4-wheeler. Other side we have Japanese made charger which is ChargeMO. The voltage rating of this is rated from 200 to 500 or even higher. It has also one connector gun and it can be utilized for 4-wheeler. We have type 2 AC charger. So, here we have level 1, level 2 and level 3 chargers. So, basically level 1 and level 2 they are AC chargers, one is slow and one is fast AC charger, and another level 3 we have DC fast charger. Here we are talking about type 2. So, level 2 AC charger, which the voltage rating of this charger is from 380 to 415 volt. It can be connected with this battery range and it can be utilized for 4-wheeler, 3-wheeler as well as 2-wheeler from the same connector gun. Other side we have slow and moderate chargers which stand as Bharat DC 001, and the rating of the charger is varying from 10 kilowatt to 15 kilowatt, and the voltage rating of these are varying from 48 to 230 volt, and these charger can be utilized to charge 4-wheeler, 3-wheeler and 2-wheeler. So, if we classify the charging, we have home charging and public charging. So, home charging is nothing but from a single phase socket we can draw maximum of 15 to 16 ampere current, and the power level could be rated from 2.5 kilowatt to 3.3, not more than that. However, public charging it is the essential need for adoption of EVs, and from outside home these Bharat EV standard they recommends the electric power needs to build and payment also. So, this payment has to be collected. The power utility may also want to manage power drawn by the charger from time to time, and this is the total development of charging infrastructure in India. So, as I told you, in 2015 the FAME 1 scheme, faster adoption manufacturing of electric vehicles, FAME 1 scheme is launched by Government of India. Under this scheme total 314 electric vehicle charging stations has been developed, and it is not developed only in urban areas. Some of the charging stations has also been developed in rural areas, in hilly areas like Himachal Pradesh and Uttarakhand. However, further the government has think like we need to develop these charging infrastructure if you want to adopt these electric vehicles. So, on the other hand, government again this launched FAME 2 scheme. Under this scheme there was impressive increase of these charging infrastructure, and they have invested around 10,000 crore money to get the charging infrastructure. This is the overall charging infrastructure till now. So, till 2021 we 2021 or some part of 2023 we got these total number of electric vehicle charging stations in India. So, India has set some goals to electrifying these transportation sector by 2030, and to meet this target, total number of charging stations which will be required at 46,000 across the countries. And as we can see, till now these charging infrastructure are unevenly distributed. It is not like that every city as well as every states they have similar kind of charging infrastructure. So, there is significant discrepancy between the current number of EVs and existing charging stations. Unfortunately, the solution to this problem is not as easy as building more charging stations, and other side, private sector players like SMB owner and RWAs complain about the high cost of charging station, which discourage them from participating in charging infrastructure opportunity. So, this is the state with the highest number of registered EVs in different states like Uttar Pradesh, Maharashtra, Delhi, Karnataka, Rajasthan. We have two-wheeler, three-wheeler and other four-wheeler buses, HMV, as we have different these vehicles in all these states. Now, apart from this development of charging infrastructure, there are some other obstacle also. So, obstacle to nationwide EV charging infrastructure in India, which include inadequate power grid, lack of public charging infrastructure, geographical vastness and diversities. So, if you go the first obstacle, that is inadequate power grid. So, India growing power demand, which has been increased by 9 to 10% in the first of 2023 alone. So, as number of EVs are increasing, there is extra burden on the electricity grid. As we can see till now, in some of the part like rural areas where there is 4 to 5 hour power cut in these areas, and if we put extra burden on the electricity grid, this may increase. So, we have to think about some alternative solutions by which we can support this power grid. So, one of the solution could be we can adopt the vehicle to grid technology. The other side, we can have more contributions from the renewable energy generation like solar and wind, and this increase the burden on power grid. This may significantly increase in the strain, and adding EVs to the grid which will result in frequent power cuts, and especially as I discussed, it is true for rural areas. Now, we have power shortage which can be which discourage the EV adoption by reducing prospective EV owners confidence about being able to reliably charge their vehicles, right. So, if somebody has a vehicle and he is going to the charging station, and what did he find? There is no electricity at the charging station. So, this may discourage the EV owners, and adoption will be difficult for the customers. So, reduce consumer confidence also discourages private sector investment in EV infrastructure by increasing the EV loads, which put further strain on the power grids and result in the voltage and frequency variation. So, as these parameters are very important from distribution network point of view. Suppose we have large number of vehicles, and the power required by this vehicle is very large. So, at the point of common coupling, there may be a frequency in the there may be a variation in the frequency, and which could affect the the neighbor loads which are connected at the same point of common coupling, because frequency is directly proportional to the active power consumption, or as there is variation in the active power, this frequency may vary. However, other side, these charger are having power electronics converter which could have DC to AC as well as AC to DC and then DC DC. So, some of the reactive power will be required by if we have connected some reactive load. This may this reactive power variation could affect the voltage at the point of common coupling, and which could be realized like there is sag and swell in the voltage, and further it can affect the neighbor loads, and we have to think about proper control over voltage and frequency variation whenever we are going to increase the EV loads. Now, other obstacle for adoption of these EV charging infrastructure, lack of public charging infrastructure. The Bureau of Energy Efficiency, it is expecting there are 46,397 public charging stations to be built across 9 cities by 2030 for faster adoption. Currently, India has only 5,234 stations which are scattered across various states. Despite the push from the government, retail stores, small business owners and other private sectors which may still be hesitant to provide public charging infrastructure at their premises. They are concerned about the significant capital these charging stations require. They may also lack awareness about the potential benefit these stations could yield for their business. In the meanwhile, prospective EV owners are still they are worried about these vehicle range. Identification of location of charging station in India is also one of the concern. Other side, if we see geographical diversities, so for example, some of the EV charging infrastructure should be resistant to waterlogging, which is common in certain area during 4 months of the year. Furthermore, due to different population density and travel pattern, rural area may require entirely different charging infrastructure from urban areas. The compound the issue, these rural area may not have sufficient EV to justify the investment. Now, solution to address these obstacles, we have here 4 points. To increase the public charging infrastructure, we have to integrate renewable energy sources with the grid, with the vehicles, development of fast charging infrastructure and fast charging technologies. We have to provide incentive to private sector investment also. So, increase public charging infrastructure, we have to, as now this government of India also thinking to launch this FAME 3 scheme to further growth so that people can adopt these electric vehicles and further growth in the EVs. So, furthermore, the Ministry of Power, Energy Efficiency Services Limited initiative has encouraged private player to build 810 EV charging stations, and the government also providing more education on the benefit of charging solution for business and simplifying the installation process. These incentives must continue in order for India to reach its EV charging infrastructure goal. The other one, integrate renewable energy. We have to integrate these renewable energy sources with the charging infrastructure to reduce the burden on the grid, as well as to provide the energy when there is outage from the utility grid. We have to also think about installation of energy storage system at the charging stations, which could also provide the solution for these roadmaps and target, which could help for this establishment of charging station in India. And this is the installed capacity of renewable energy sources in India. So, still we are getting 53% electricity from fossil fuels, and there is contribution around 23 to 24% from the renewable energy. So, the contribution from the renewable energy side we have to increase. Then we have developed fast charging technologies, and like slow charger take anywhere from 1 to 6 hours. However, fast chargers can take less than an hour to charge our vehicle. We can charge our vehicle within 30 minutes. That can elevate range anxiety, especially for long distance travel from one place to another. Fast charging technology can also cut down the total required number of charging infrastructure. So, development of fast charging infrastructure, public charging infrastructure, the contribution from the private companies are also required. So, private companies are also investing in the development of fast charging technologies, with many companies introducing fast charging station across the country. We have to also incentivize private sector investment. So, to provide the incentive to the private sector investment, the government has introduced several initiatives and policies. Reason to implement EV charging infrastructure in India: obviously reduce greenhouse gas emission, increased contribution of renewable energy sources, and the third, and not I mean we can say last, but economic growth is very important in case of development of the charging infrastructure. Reduction in greenhouse gases. So, the chart provide a glimpse into how different countries are progressive toward meeting EV adoption goal by 2030. Here it is a chart of life cycle where greenhouse gases emission versus 2021, and if we expect if all the vehicles will be electric vehicles by 2030. So, we can see there is at the x axis we have number of years, at the y axis we have different life cycle gas house emissions. So, increase the use of renewable energy, which will help in the different aspect. And then powering ahead, India's successful transition to electric mobility is contingent upon developing a robust charging infrastructure. Although India faces many challenges in creating a reliable and efficient charging network, the government is working to increase the number of public EV charging stations. These measures could make India a leader in sustainable transportation and clean energy. Developing EV charging infrastructure in India can also create new jobs opportunity, boost economic growth, and enhance public health and overall quality of life. If India can achieve its goal, it can inspire other countries, thereby ultimately creating a more sustainable and greener future for all. So, with this, thank you for participation or participating in today's lecture on EV charging infrastructure in India. We explored the different component of EV charging infrastructure and the various scheme which has been launched by Government of India to accelerate the EV adoption. I hope this session has provided you with valuable insights and a deeper understanding of the component and the status of charging infrastructure in India. And please review this lecture material. Feel free to post any questions or comment on the forum. Looking forward to seeing you in the next session. Have a great time, keep learning. Thank you.